Okay. Great. So my name is Yogeshwar and I currently work as a software developer in a big data team at Adobe Systems. Previously, I have experience in personalization domain, mainly creating microservices architecture, designing, implementing and maintaining things and leveraging cloud, particularly AWS. So that's my introduction. So quickly, let's get started with the session as we have a lot of ground to cover today. So let's quickly walk through the agenda of today's session. As you would know that today's session is on distributed cache design. Now before we delve into designing of the cache, I would like to briefly introduce the idea of what exactly is cache. What are the situations in which you would like to introduce a cache in your architecture? Now what are the general patterns in which you can leverage a cache to speed up certain things or certain operations in your architecture pipeline? Finally, we'll start with the designing of the cache by elucidating or by going through the requirements first, that what all are the requirements that we are going to cover in today's session's scope. So we are not going to go for a full-fledged cache like Redis or Memcached. I'll just concretely break it down to few requirements, and then in the next phase, one by one, we'll see how those requirements can be met. Right? What are the design decisions that we need to take in order to meet those requirements? So I hope we are clear with the agenda. So what exactly is cache or cache? Now, in this session, I'm gonna ask you a lot of questions. I want it to be interactive, right? So it would be helpful if you could write on chat boards, right? So here comes the first question. What all are the different places where in a computing system data can be stored or retrieved? So think about your college days or like a computer architecture book. What are different places? So yeah, please mention it in a chat board. So Ashish has responded it's database or disk, and so I'm looking for particularly hardware. And database is a software which utilizes. I'm specifically looking for the underlying hardware. Great. So Shubham has mentioned CPU registers. Prakhar is saying CDN cache. Aman is saying primary memory and DB. Great. So aligned in the same direction. Rupali is mentioning RAM. Great, 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 great. So I think combinedly, if we take union of all the responses that you have provided, I think we will cover all possible locations. So I could come up with these three simple locations. So CPU registers, right? These are the registers that we generally study in our computer architecture course, like accumulators and different kind of memories which are very very close to CPU for directly accessing. Second kind of storage is RAM, that is random access memory, or the primary memory. It's a kind of volatile but primary memory which comes uh, just next after CPU registers. Third kind of storage that we have got in our computing systems of current generation are the hard disk or the permanent storage. Now, here comes another question. What is the speed of access for these three locations? Can you give me a speed of access pattern like A greater than B greater than C? Quickly on the chat board. Ashish has responded. Neeraj has also responded. Great. Dhananjay, great. Right, right, correct. Vinu has also responded. Great, great. So I think all of you are quite clear on this thing, and so this is quite evident, right? That CPU registers being closest to the actual processor or actual part of the system where the computing takes place. So they are going to be much more quickly accessible to the processing engine of the computing system. Second is RAM or the primary memory, and the third is permanent storage or the hard disk. Now, what do you think will be the costing of these three kind of storage? What will be the order of the costing, like which is gonna be more expensive storage and which is gonna be least expensive storage? May I have quick responses on the chat board, please? So Prakhar has responded. Great. So we know that speed comes with a cost. So greater the speed of access, the same is gonna be the cost order, right? So CPU registers are more expensive, and that's why they are very less storage is available in terms of CPU registers, right? And then the RAM and then the hard disks, right? So, what exactly is cache? Cache is a storage engine which leverages second kind of storage, that is RAM or in memory storage. Now, why or when exactly do you need a cache, right? Let's try to understand it with the help of an example. Okay, so I have taken a kind of simplistic example, but I hope it will clear out the concept. It will make you appreciate the concept of utilizing the cache. So let's take the example of IMDb top movies. Now, think of it for a while. These top movies are gonna be viewed by millions and millions of users again and again, right? And one more thing, does this list of top movies changes very frequently? Think about it for a while. There are certain movies like Godfather and Redemption. These movies remain in the top list for decades, right? So this kind of data is being read very frequently, and this remains kind of almost static, right? This is not that much frequently changing kind of data. I want you to primarily focus on this part, that this is high read frequency data. Can we call it? Is this thing clear to everyone? Because this is the fundamental aspect of whatever we are going to cover in entire session. Is this thing clear that there are certain pieces of data which are read much more times than they are written or updated? Can I have a quick confirmation on the chat board that if this part is clear, that this list of top movies, it's gonna be read by millions of users again and again? Is this clear? Okay, so Venu says agreed, Bhupali says yes, go ahead, Prakhar, Ashish, great. So I think with this fundamental thing clear, now we are good to go for understanding the why exactly we need a cache, right? So I want you to first think of a counter example, or the example which or the way in which we would design if there was no concept of cache. Correct. Where would we generally store the data, store this list, right? If we didn't had any concept of cache for this high read frequency data, we would put it in some kind of database. Correct. Now, many of you or most of you would be knowing that database is disk based storage, correct? Now think about this question: what will happen if this list of IMDb top movies is stored in a database? Think about it and respond in chatbot. Like, I want you to think in terms of uh, load on the database and the latency or the time that will be taken in responding to a request. Think on these two particular parameters, that is latency and the load on database. What will happen if this is stored in database? So Ashish is saying slow retrieval, slow response time. Slow response time means higher latency. Dhananjay has also mentioned same. Others, please. Yeah, so Neeraj is saying for millions of concurrent requests, speed would be very slow. Okay, that means database will be overloaded. Ashish is saying that high amount of disk read operations. Great. Manish is implicating on the costing side of thing, that is high cost if we add more DB. Great. Okay, great, cool. So Manish, for now I would not emphasize that much on costing side of thing. Currently I would focus mainly on these two things, that is the latency and the load on the database. So great, I think all of you have responded in the correct directions. Correct. So database will be highly overloaded by large number of queries, right? We are saying that IMDb is something that is being accessed globally, worldwide, right? So millions of users are going to query for these movies, and database will get highly overloaded. This is one part. Another part is time taken in responding to requests. Now, what exactly are the steps that will be taken in responding to a particular request? First of all, there will be a network call to the database. Now, once this network call to the database is made, another thing or another operation that takes place will be retrieval of data from the disk based storage. So, these are the two things, and these are going to consume a higher amount of time, right? So, these are the two significant disadvantages that we can see when we store the data in database. So here comes the questions. How do we reduce load on database? How do we reduce the latency? Right? So I think by now all of you are somewhat clear that solution is cache. Let's see how cache solves this problem. Now I want all of you to look at this diagram or look at this picture from left to the right. Glance over it for a while. I'll just pause for a few seconds. Great. So let's try to understand what's going on in this diagram. There is like it's quite many details are there, but we'll walk through step by step. So on the left side, you can see that there is a client which is making request for fetching these top movies. This client could be your mobile app or a browser or anything, any device, right? This request for top movies is going to a server. Now that server is going to fetch those movies from database. Now I want you to first consider the scenario when there is no cache. So server is gonna fetch those top movies from the database and will respond back to the client. And definitely, as we have discussed in the previous slides, that it is going to take a lot of time in terms of latency and it will overload the database. Now, what happens when we introduce a cache in between or a layer of caching in between? So, when the server receives the request, first of all, it's gonna check in the cache that whether the cache already contains this particular set of data which the client has requested. In case when the cache does contains, that is the server founds that the cache is having the data which the client has requested, it's gonna fetch that data from the cache and return it back to the client. This situation when the data is found in the cache is called cache hit. Another situation can also arise that server looks up for the data requested by the client, but the cache doesn't have the data. That situation is called cache miss. Now, what does the server do in case of cache miss? It's gonna look in the database because database is the source of truth for us. That is, all the data is always going to be in the database. So in case of a cache miss scenario, it looks up for the data in the database, fetches that data from the database, updates the cache with that data, that is, adds that data in the cache, and then returns the response to the client. Now, why does it adds that data in the cache? So that when next time any other client requests the same piece of data, server will find that data in the cache. Is this point clear to everyone? May I have a quick confirmation or any doubt regarding this? Please post in the chat board. Ashish is confirming, he's got it. Shashank has got it. Aman says clear. Neeraj says clear. Bhupali, Vinu, is it clear to you? Subham, clear. Okay, Bhupali is saying repeat once. Okay, so I'm gonna repeat it once quickly. Great. So just for the sake of understanding, I'm gonna repeat it quickly that there are two scenarios which are possible. Server looks up for the data in the cache and it founds the data in the cache. This is called cache hit. In that case, server quickly returns the data back to the client. In another situation, that server looks up the data in the cache but does not finds it there, this is called cache miss. In the situation of cache miss, server is going to fetch that data from the database, add that data in the cache and respond it back to the client. Now this addition of data to the cache results in presence of this data when another request comes in future for the same piece of data. Is this clear? Bhupali, is this clear to you? Great. So Venu has asked a question, if we keep on adding more data to cache, how are we maintaining space usage of cache? Great question, Venu. So these are the questions that we are gonna tackle in the cache designing part of the session. Great. So I'm gonna quickly go through cache access patterns. Particularly, I want to emphasize on the ways in which we can write data to a cache. Now, glance over this diagram, left to right. There will be a couple of diagrams in this session that you need to glance them and then I'm going to explain them. That will be a better approach. So please have a look at it. There are numbers I have put. So those are the sequence in which these steps take place. Cool. So first strategy in which you can write a certain piece of data to a cache is called write through. Now the reason why it is called write through is that data is first returned to the cache and then returned to the database. Now let's walk through this sequence of diagram from left to right. There is a client which makes a write request to the server. For example, some piece of data you want to write to the database. So you make a request to the server. Server will write that piece of data in the cache, then will write the same piece of data in the database as well. Once it has received the confirmation of successful write from both the database as well as the cache, then it confirms back to the client that yes, your write request is successful. Is the pattern clear? May I have quick confirmation on the chatbot? Yeah, great. So basic idea, if you want to remember right through, the basic idea is just that server acknowledges back to the client only after successful write has taken place in both the storage, that is cache as well as database. Couple of guys have confirmed. Thanks a lot, guys. Thank you. So now I want you to think about pros and cons of this particular writing strategy to the cache, write through strategy. I will go back to the diagram. Now I want you to think about what are the pros of this particular strategy. Shubham has mentioned that for write through, shouldn't the cache be responsible for writing to DB? Now this is something that I also had little doubt, but as far as my knowledge is that the mechanism of writing is that it is the server which writes to cache and then it also writes to database. Now this writing to DB, I haven't come across architectures that where the cache is writing to database. It is the server which writes to both the cache and the database. Shubham, I hope I answered your question. So Ashish is responding that pros is that consistency. Okay. Manish is saying on the same lines, data consistent. Prakhar is saying asynchronously. Couldn't get you, Prakhar. I didn't get you what exactly you mean by asynchronously. Tanay is saying that this mechanism is easy to implement. Ashish is saying since server is writing to database, this means we can have different data structure in cache compared to what we have in DB. Hmm. Mm-hmm. Okay. Neeraj is saying that it's gonna have the same data everywhere. Hmm. Okay. So Prakhar is asking one question that server to database writing, should this be done asynchronously? Now, answer is no. Because before acknowledging back to the client, server is waiting for the acknowledgement from both the cache as well as database. That means client or is blocked, that is client cannot receive a response from the server until and unless server has received successful acknowledgement from cache as well as database, and that's why these writes are taking place in a blocking or synchronous manner. I hope I made this clear, Prakhar. Prakhar, are you able to get it? Great, great, great. So Shubham is saying data can't be consistent if you write to DB is failed but write to cache was success. Okay, great. So let's go through the points that I have written. These are very simple points. Okay, before we go into, okay, so I think great discussions going on the chatbot, but in the interest of time, I would like to limit it a little bit. Thanks for your enthusiasm, guys. Okay, can you quickly think about the cons of this strategy? Like, what are the drawbacks of this particular strategy of writing? Stall data. Ashish is saying slow write speed, high latency. Okay, since writing is taking place to both kind of storage. Okay. Mm-hmm. Anyone else? What are the cons or the drawbacks of this particular way of writing data? Great, thanks Shashank. Ashish, Shubham is saying data is not consistent, high latency. Manish is saying increased latency. So primarily, many of you are indicating towards increased latency. So one of the pro that I could think of is that most recent data will always be available in cache. So if you see in write through, we are having the data is being firstly returned to the cache and the server at the same time. That means your most recent data will always be available in the cache. Now, if we take some example, for example, Donald Trump tweets something. Now, if he tweets it today, it's gonna be accessed for next 1 week by people all over the world. That means there is some kind of temporal or time based locality. To understand it clearly, that this particular piece of data, it is recent data and it is gonna be accessed again and again, that is read again and again. In the write through mechanism, since most recent data is always available in the cache, you are going to have higher chances of cache hit. In terms of cons, since the acknowledgement from both the cache as well as DB is required, write latency is certainly gonna be higher. Another situation that can happen is that since all the write requests are going to cache as well, cache may get overloaded with the request. Let's move to the second strategy of writing. This is called write around strategy. Have a look at the diagram. Hmm. So, This strategy is quite simple. Similar to the previous one, client makes a request. Now, rather than going through the cache, we go around the cache. That is, we bypass the cache and write the data directly into database. And once the acknowledgement has been received from the database, server simply responds back to the client that write request is successful. Is this clear? That rather than going through the cache, we go around the cache, bypass it, and write it directly in the database and respond it back to the client. Now, I hope this is clear. Now, I want you to ponder over this question that in write around strategy, we are not writing the data to the cache when the client makes a write request. Then how exactly does data gets added in the cache? Is the question clear that we are not adding the data in the cache while writing? So how does the data gets added in the cache? Quickly think and try to respond on the chat board. So Manish is saying when request is there shall be cache miss. Neeraj is saying with every request the data gets cached. Okay. Dhananjay is saying when it will get queried. Dhananjay is on the right direction, right? At the time of read, Tanay is saying great, great. So I think Dhananjay and Tanay, you are in the right direction. So this is what happens in the data addition mechanism. So simple thing is that when the data will be requested for the first time, server checks in the cache for the data. Obviously it's not gonna find that piece of data in the cache. It will result in a cache miss. Then server looks up the same piece of data in the database, adds that data in the cache and responds back to the client. This is how data gets added in the cache in write around strategy. Now, quickly going through the pros and cons of this strategy. So, may I have quickly like pros and cons of this strategy that you can think? Let's think in terms of latency and yeah, I would appreciate if I can get some responses on the chat board in terms of pros and cons of this particular strategy. I'll go back to this slide for you so that you can see it. And so Vino is saying low latency. Okay. Cons. So Vino is mentioning cons is that read latency will increase. Okay. Okay, Dhananjay is saying it will reduce the load on cache while writing. Neeraj is mentioning that only the frequently used data gets cached. Okay. Others, Tanay, Shashank, Shubham. Dhananjay is saying there are higher chances of cache miss. Yes. Ashish is saying initially latency would be high. And I think he means read latency. Shubham is saying each cache miss results in 3 trips which cause a noticeable delay. Yeah, exactly. Okay, cache warm up, Ashish is saying most of the requests will result in cache miss. So let's see. As some of you mentioned that only the data that is really requested by the client for reading will be cached. That means unnecessarily overloading of cache does not takes place in case of write around strategy. Cons, as it is very much clear that first time cache miss is inevitable. Third strategy is write back. Now please have a look at this diagram. So in this strategy, server responds back to the client just after receiving the acknowledgement from the cache only. So here is how steps take place. Client makes a write request, server writes the data to the cache only, and once it gets the acknowledgement from the cache, it responds back to the client that yes, your write request was successful. Now, how does the data gets added in the database? It is done asynchronously. Data is added to the database in an asynchronous manner. When I say asynchronous, it simply means that server does not wait for the database to successfully acknowledge that yes, database has successfully written the data to its disk. I hope this is clear. So let's quickly go through its pros and cons. So may I have quick responses on the chat board? Yeah. So Vino is saying, can you please go back to previous slide? Vino, this right back slide. Okay. So Ashish is saying low latency and cons. Data might become inconsistent. Great. Write to DB can fail and result in inconsistency. Okay. Anyone else, please? Okay. So yes, you are right. So as if we see in this particular architecture that since the acknowledgement is done back to the client once the write has been successfully acknowledged by the cache only, so it's gonna result in very low latency. However, if we see at this diagram, there might be case that data gets successfully written in cache, but it does not get synced to database properly due to one reason or the another. Maybe network failure, maybe disk failure, or anything can happen. But if the data gets synced in the cache but does not get synced in the database, this is gonna result in inconsistency. So with this background done, let's delve into cache designing part of things. So whenever we are given any software system to design, first of all is to have a clear cut scope of features, functional, non-functional, that we want to deliver upon. So these are only few points for the sake of discussion in this particular talk we are going to cover. First, scalability. Secondly, availability. Third is how do you efficiently utilize the memory, right? Fourth is how do you build mechanisms so that in case of a failure or crash you can recover back. And finally, we are going to do a quick walkthrough of how do you estimate the capacity in terms of number of servers that you are going to require in your distributed cache. So scalability. May I have quick responses on the chat board that what exactly do you understand by scalability? This term scalability, we heard it quite a lot that your business model should be scalable, your pipeline should be scalable. So what exactly does it mean by scalability? Okay, so Vinu has asked a question. Vinu, I'll tackle your question in the last part of the session. Let's park it for now. Okay, so Ashish is saying scalability means handling high throughput. Okay, Aman is saying it should respond properly for higher number of requests. Ashish is saying lots of requests per minute. Prakhar is saying changes can be accommodated if requests increase. Okay, okay. Scalability again Neeraj saying high handling high number of requests. Manish is saying without change in latency you are handling requests. Okay, okay. Tanay, Shubham, Bhupali, Dhananjay. Great. So most of you are indicating towards handling higher and higher levels of data. That is what you are referring to as scalability. I think there is another aspect as well. It is not just about ability to handle higher loads, it is a property of the system by virtue of which it can handle increased or reduced load by increasing or decreasing the resources. So when we say scalability, it includes both aspects, that is scale up and scale down, right? So when load is high, you can add resources, and by resources I mean there can be computing resources, for example your servers, your machines, yeah, EC2 machines, something like that, or it could be your storage resources, your disk database nodes, right, or your SAN disk, right, storage area network disk, something like that. Another aspect is when the load is low. For example, there are certain companies which have seasonal traffics, right? And if your company is going to get a spike during Christmas, it makes sense to increase the resources during Christmas season. But when it is Holi, you want to reduce that load. You want to reduce the resources uh, that you have included in your pipeline because you don't want to incur the costs, right? So scalability means ability to scale up as well as down in response to the traffic. So here comes the question. In our distributed cache cluster, how do we scale up and how do we scale down? So there are a couple of strategies which are used for scaling in general in distributed systems. I would request all of you to quickly think about them and write in chat pod, please. So I want you to think about the scaling strategies that we have discussed in the previous sessions as well. Yeah, may I have quick responses on the chat pod, please? Okay, so Manish is mentioning consistent hashing. Others? Tanay is saying add resources on demand. Yes, Tanay, you are right, but I want the particular strategies that how you add resources. What are the patterns, architectural patterns? That's what I'm asking. Correct. Neeraj is saying increase data nodes and remove data nodes when not needed. It's correct. So I want you to name the specific strategies. That is clear that you want to increase and reduce. But what exactly are the strategies that we leverage in distributed systems? Like the algorithms you can call or the architectural styles of distributed systems. Dhananjay is saying load balancer will take care of this. Shubham is mentioning service discovery, zookeeper, gossip protocol. So these all are protocols and technologies. What I'm asking is for particular uh, architecture styles in which data is stored in the distributed systems. I think we covered it in the previous two sessions. Let me go to the next slide. So these are the uh, these are the strategies which we have discussed in the previous sessions. You can have the database which is sharded, okay, sharding or partitioning the data. Another is master slave kind of architectures. Another thing that we have discussed in the previous session in pretty much detail is consistent hashing pattern. So in this session I'm not gonna go into details of each of these because they are vast, they are quite a significant topic by themselves. But in terms of approaches for scalability, these particular architectural patterns can be leveraged while designing scalable distributed systems. Second aspect is availability. What exactly do you understand by availability? What do you understand by this term called availability? Aman is saying capped forum. So I think I'm asking only about the A part of cap, Aman. Manish is saying 100% uptime. Okay. Shashank, Dhananjay, Tanay. So what exactly in general if I'm saying that I am available, let's let's forget about the distributed systems. If I say I'm available, what does that mean? Okay. Neeraj is saying data should be ready for access. Prakhar is saying less downtime by redundancy. Okay. Ability to withhold disasters. Tanay is saying. Sasank says available 100%. Okay. Dhananjay says that it's always available when queried. That is, data will be available when queried. Okay. Ashish is saying that return data for each API call. Okay. So I think you all are in the right direction and you have got it. Let me just go through this simple concept that when I say that I am available, that simply means that I'm gonna respond to you. So let's think of it for a person to person communication. If I'm saying that I'm available at this particular time, let's think of it a phone call example. I say that I'm available at this particular time. That means when you call me, you expect me to respond. Otherwise, how would you know I'm available or not? Right? So this is the basic idea of availability, that is whenever you are being queried, you respond back. Now let's understand it in terms of database or data storage systems, that is cache or databases. So whenever a request for a certain piece of data is made, no matter whatever the situation, database will always respond to that particular query. This is called availability. Shubham is saying that available up to SLA. Yes, that is correct. So, what Shubham means by SLA is that you can ensure that 99.999% times your database responds to the queries. But there is a chance that sometimes your database may not respond to the query because of any kind of reason. For example, disk failure, natural disasters, network failure, anything can happen. So this is called availability. We can say it like percentage availability or SLA driven availability. That means in 99.99% of the cases, database is gonna respond to the queries. I hope the concept of availability is clear. Is there any question regarding this availability thing? Anyone having any doubt regarding this concept of availability? It's clear. Okay, great. Cool. So let's proceed. Let's take the counter example. When do you think data can become unavailable? We say the database is going to respond to the queries. That means that it is available. When do you think data can become unavailable? May I have responses on the chat board, please? Manish is saying when service is down or stopped, situations like DDoS attacks, okay, great. Database is down, data is not updated. Ashish is saying that data is not updated and being updated. Okay. Okay. Neeraj is mentioning that when query has no response, it fails. So that is unavailability, Neeraj. I'm asking for the situation when this thing occurs that query doesn't receive a response. So as simple as that. When you have lost the data for any reason, your database cannot return that piece of data. For example, if you ask database for my profile for a person named Yogeshwar and my profile is not there in data or it is lost due to some kind of reason, that means it is unavailable. That is, when you lose access to data or you lose the data itself, then it becomes unavailable. Okay, so how do you think we can ensure high availability? In other words, how do you think we can ensure that data is not lost? Aman says keep a replica of each service in case one service fails. Okay, retry mechanism in service. So let me make my point clear that I'm particularly asking about the data being lost. I'm not saying that service being lost or service not able to access the data. I'm saying unavailability takes place when the data is lost. So Shashank is mentioning retry mechanism in service. What will happen, Shashank, if the data itself is not there? Even if you retry 100 times, it's not gonna get that data. Dhananjay says that backup server, if main server is down, backup server is up. Okay. Prakhar says distribute to multiple regions in a master slave topology. Manish says let's maintain the replicas. Okay, great. So simple as that. That if you think that you may lose one, if you have only single copy of data, there is a chance that you may lose that piece of data forever. Suppose if you had multiple copies of data, okay, then there is a lesser probability that you are going to lose all of that data. You may lose one copy, but another copies are gonna survive. Suppose there are n copies or n replicas of a particular piece of data, then even if few of them are lost, others will survive and you will be able to recover that piece of data. And that is how you ensure availability in a distributed data storage. Next is fault tolerance. So the words like fault, failure, error mean different things in different contexts. For the sake of this particular talk, let me explicitly make it clear that fault means that when your cache is lost, that is, all the data that is present in the memory of the cache is lost, the ability to recover from such a failure, that is what I am calling as fault tolerance. So how do we ensure fault tolerance? Can you think of some of the ways in which we can recover the data of the cache if the entire cache is lost? May I have responses on the chat board? Like, think about things from the database theory you would have studied, like different mechanism of restoring back the database or something like that, right? Think on those directions and try to respond on the chat board. Okay, Ashish is mentioning backups. Okay, Shashank says checkpointing. Tanay says rebuild cache. So Tanay, that's exactly what I'm asking. How do you rebuild the cache? Neera says restoring the backup. Okay. Mm-hmm. Others? Great. So there are two particular strategies that are quite prevalent to recover or rebuild the cache when the cache's data is lost. First one is called log reconstruction. Second one is snapshotting, or in other words, you can call it taking backups, regular checkpointing. So these are terms for the same kind of thing. So let's understand the log reconstruction first. Have a look at this diagram. There is a client service, there is a cache. Now, client service is gonna issue commands to the cache. For example, it says the first command is set key1 equals val1, which means for key1 store a value of val1. Now, for each of the commands that cache receives, there is another service, or we can say there is a file being maintained in which each of these commands will be stored or persisted. So the set key1 equal to val1 is accepted by the cache, and this particular command is written in this command log file. Command log file is nothing but a log of all the commands that have been issued to the cache so far. Now, once you have this command log file ready, what will happen in case the cache is lost? Can we not simply replay back all the commands from this command log file, and that will populate the cache again? Is this point clear? That utilizing this command log file, we can simply replay all the commands, and this is gonna populate the cache again. Pretty simple, yes? Yeah, great. So many of you have acknowledged. Great, thanks. So okay, so I think there is one question by Prakhar is saying that simply restart the cache and cache will eventually populate again. So Prakhar, yes, you are definitely right that cache will eventually populate again, but during the time when cache is being populated again, your service is going to receive higher number of cache misses, right? These kind of fault tolerance mechanisms are there to ensure that you reduce the cache miss. Is this point clear to you, Prakhar? Great. So Prakhar says agreed. Great. Thanks a lot, Prakhar. So this is how it takes place. So you can simply see that on the right side there are a couple of commands that I have written. Just go through them. Set key1 equal to val1, set key2 equal to val2, then you get the key value for key1, then again you set key1 equal to val3. At the end of these four commands, this table on the right side will represent how the data in the cache will look like, and these commands on the left side will form the content of the command log file, and we simply replay it, and I think it's clear to all of you by now. Second strategy is called snapshotting. Okay, snapshotting simply means that since cache is a RAM based storage or a volatile memory based storage, At regular intervals of time, you tag the copy of all the data that is present in cache's memory and persist it into a permanent storage like disk, kind of similar to taking regular backups of the data present in the RAM's memory. Now, in a situation when your cache goes down, what do you do? In a situation when your cache goes down and you have backups available to you in terms of snapshots which you are taking regularly at different points of time, what do you do? Restore from disk, Vinu says. So, pretty simple, I think. Yes, Ashish is saying populate data to cache from backup. Pretty simple. Yes, it's great. So, simply persist the copy of this is the idea I think I have discussed, and you simply load it back into the cache. Great. So, next thing that we want to discuss is efficient memory utilization. So this is where we discuss the part which Vinu mentioned in the earlier section or requested to discuss. So efficient memory utilization. Why exactly do you need it in the first place? Why can't we simply just keep on writing to the cache and let it be there? Why exactly do we need efficient memory utilization in the first place? Think about it and try to respond in this. Okay, so Ashish says that cache would keep on growing, leading to slow latency and high storage cost. Okay, great. Others, please. Neeraj says that we cannot cache all the data. Okay. Tanay says that RAM is a costly storage. Okay. Others. Okay, Manish says that scanning will be faster. Didn't quite got that, Manish. Aman says that we need less data, which is frequently required. Okay, and caching storage is costly. Okay, cool. So I think many of you have responded in the correct direction. That is, first is that RAM is smaller than disk. That is, it is a limited amount of storage. Second is cost aspect. That is, you cannot keep on adding data to cache. Since it is costlier, you cannot have infinite RAM available in your cache. So that's why you need to efficiently utilize whatever amount of RAM is available in your cache cluster. So here is the question: what will happen if we keep on filling the data in cache and never delete it? Okay, so think about it for a while. So we have discussed those two aspects, but I want you to think on this particular question, that if we keep on filling the data and never delete it, okay, Ashish says that cache would overflow. Okay, Manish says lot of unused data. Cache will grow significantly, Neeraj is mentioning. Aman says that irrelevant data might be there in the cache, while the frequently read data will not be there, which is what exactly should be there. Okay. Okay, Vinu is asking what is cache overflow exactly. Okay, great. So let's take all these questions. Okay, Neeraj mentions that old and not required data may be there in the cache. Okay, great. Okay, so okay, Bhupali is mentioning that we need to add Nitin. So Bhupali, please request Nitin to request for access, and just ask him to join in and I'll admit him. Great, so let's discuss this thing. If we keep on filling the data in the cache, right, pretty soon your cache is gonna get filled up. Another aspect is that the data which is added earlier to the cache will be there in the cache, but your recent data or the new data won't be added in the cache. Now, there are times, or in general, the data which is read recently is more likely to be read again in the near future. That means if new data is not added in the cache, your cache is gonna result in high cache miss. That is, your service is not going to find the data which it expects to find in the cache. So I think this point is pretty clear. So Vinu asks, what exactly is cache overflow? So cache overflow, simply you can understand that you want to add the data to the cache, but it doesn't have any more storage left because earlier added data has occupied all the storage. So there, I wouldn't really call it overflow, I would call it storage limitation. That would be more appropriate term to call it. So Dhananjay says that purpose of cache is not achieved in case we keep on adding data, and it will behave as hard disk only. So Dhananjay, you are partially correct in here that yes, purpose of cache won't be achieved, but it won't behave like a hard disk. Whatever data is there, that will be accessed faster than the hard disk, but what is not there will simply result in cache miss and it won't even be accessed. So partially correct there. I hope I made it clear, Dhananjay. Is it clear, Dhananjay? Great, thank you. So we know that we want to be able to access recent data. That means we have limited storage. If we want to be able to add new data, we definitely need to delete some data. Okay, now can you think of some simple methods or some simple algorithms which you might have studied in your college days, that using which data can be deleted from the cache? Okay, Ashish says LRU cache. Okay, any another mechanism? Okay, so I want you to think in terms of that you want to be able to keep the uh, recent data in the cache. Okay, Ashish is saying that least frequently used. Okay, others. Dhananjay says MRU. I think it's most recently used. Okay, most frequently used. So think about it, Dhananjay. Why would you want to delete the data that is most recently used? Okay, the purpose of cache is to keep that data which is gonna be accessed again and again, so that there are higher amount of cache hits and the calls to database are minimized. That is the purpose of cache, right? So okay, great. So let's see, these are the two simple strategies that can be utilized for deleting older data from the cache so that newer data can find place to be stored. First is called TTL. TTL, or time to live, simply means that when you store a particular piece of data in the cache, you assign a time to live. That is the time duration for which this particular data is gonna be stored in the cache. For example, store my profile in a particular cache and you set a time duration of 1 week. Now, after 1 week, my profile will be automatically deleted from the cache. This way, all the older data is gonna get automatically purged or deleted from the cache and newer data will find place. This is called TTL, that is time to live mechanism. Second is LRU or least recently used strategy. What exactly does it mean? LRU simply means that whatever piece of data that was least recently used. So let's think of it in terms of timeline. For example, your cache has got, suppose, 1 week worth of data. Your cache has got 1 week worth of data, that is, let's suppose today is Sunday and our cache has got last Monday to today's data. Okay, now there will be certain data points which will be accessed on different days. Now, whenever a particular piece of data is accessed, that is read from the cache, we store a timestamp of that particular access. For example, my profile was accessed on Monday, Manish's profile was accessed on, let's say, Tuesday, let's say Vinu's profile was accessed on Wednesday, Bhupali's profile was accessed on Thursday, Neeraj's profile accessed on Friday, so on and so forth. Okay, now my profile was accessed on Monday and was not accessed any time after that. That means my profile is least recently used profile. Now, when a new data is to be written into the cache and you need to free up the space from the cache, whose profile do you delete? You will delete my profile because it was least recently used. Is this fundamental definition or understanding clear that what exactly is LRU? We are not going to go into the implementation of LRU, but is this clear that what exactly is LRU? Anyone having any doubt, please mention in the chat board. Okay, Ashish is clear. Thanks, Ashish. Others? Any doubt, please ask. Yeah, Bhupali says clear. Thanks, Bhupali. Okay, okay, great. So I think this is pretty much clear. Thanks a lot, guys. So I think we have all studied this in our operating systems book in the college. So, and it continues on from there. Now the final part of designing a system is that you need certain numbers, right? You want to estimate that how exactly is the storage requirement or what exactly is the storage requirement of your system, and in turn you want to estimate how many nodes or servers you are gonna require. Why do you want that? Firstly, you want that because you want to somewhat estimate in advance that how much big of a cluster you require to be able to serve your clients properly. One thing. Another thing is costing, that each resource that you add in your cluster is gonna incur cost to you. So you want to be able to estimate the numbers so that you can estimate the cost projections, and these are important aspects of being a I would call it a product person. If you are a product person, you don't just think from features perspective, you also think from business angle. So that's why costing is also important. So let's see this storage and capacity estimation. So I'm gonna focus on two part only. We won't go into the costing side of things. Let's focus on the storage requirements for our cache and then figure out how many nodes will be required to meet that storage requirement. Suppose that per object size that we store in cache is 1 KB, 1 kilobyte. At any point of time, I want to cache 5 million such objects. Can you quickly calculate how much of RAM storage I'm gonna require? May I have quickly answers on the chat board, please? How much of space or how much of RAM storage I'm gonna require to store 5 million objects of 1 KB each? Can you quickly do this simple calculation and respond on chat board, please? Okay, Tanay says 5 GB. Manish says 5 GB. Others? Okay, so just to make it clear that million is 10 raised to power 6 and kilo or k means 10 raised to power 3. You simply need to multiply them, what you get, that's how you can estimate. Yeah, Neeraj, correct. Great. So nothing hi-fi here, it's pretty simple calculation, that is 1 KB times 5 million. So simply k 10 raised to power 3, m 10 raised to power 6, 10 raised to power 9 it becomes, and we know 10 raised to power 9 is giga or g, and byte remains byte, that is 5 gigabyte. So this much storage you require. Now there is one assumption that I have taken in here. Let's see that. You require 5 GB when only one copy of the data is stored per object. But we discussed in the previous slide that we want to ensure high availability as well. How do we ensure high availability? By keeping multiple copies of the data. The number of copies of the data that you keep is called replication factor. Now suppose your replication factor is 3, what will be your storage requirement now? Quick responses, please. She says 15 GB, Tanay 15 GB. Others? So yeah, great, Manish. Pretty simple, right? To store one copy per object, you need 5 GB. To store 3 copies per object, you are gonna require thrice the storage, simply 15 GB. Correct? So 15 GB is the amount of storage that you are gonna require to keep your cluster highly available or available to the replication factor of 3. Okay. Now let's go through this calculation. Let's understand it's pretty simple and quite straightforward. Now I want you to estimate the number of nodes that you are gonna require. So let's suppose one particular node or one particular server in our distributed cache system is of 3 GB RAM, and we know that total storage requirement is of 15 GB. So how many nodes we are gonna require? It's already written there, but I hope this is clear. So we are gonna require 5 nodes, 15 GB, that is the total space requirements, divided by per node capacity, that is 5 nodes. So this is a very like high level walkthrough, but I hope this gives a sense of how you can estimate the number of nodes that you are going to require in your distributed cache cluster. Once you have the number of nodes, you can easily calculate how much costing it's gonna cost you to maintain this cluster or to run this cluster over a duration of, let's say, some years, right? So this is how you design certain things. You take the requirements one by one, you tackle through those requirements, devise strategies and solutions, and see that these different requirements work together in a holistic manner. That's the essence of system designing. So that's why we took this particular example of distributed cache. So I think we have 5 minutes left. Anyone having any questions, please feel free to share on the chat board. Okay, one question of Vinu was there. Okay, yes, it was there. Let me just scroll up. Actually, I also forgot her question, so let me just see. Okay, so Vinu asked one question, that if there is load on database and server timeouts to query, after retrials, we can respond back to user saying data is unavailable. Okay, so Vinu, could you please like explain or write it back, like what exactly is the question here?
I think the question is different. She has copy pasted in the chat.
Okay, so in write through, how did we ensure data consistency? Did we erase the entry from the cache if db results in array? Okay, great. So let me go back to that slide, write through once. Okay, so Vinu, in write through, your server is gonna respond back to client with a successful acknowledgement only and only if data is returned successfully to cache and data is successfully returned to database. There is an AND condition. Okay, that means if any of them does not respond to the server that yes, data has been successfully written, server won't respond back to the client with a successful message. It will simply give back an error to the client. That means it's gonna return back some kind of error response to the client, not a successful one. So question regarding how did we ensure data consistency? It's quite simple. Only when the data is written to both of them, you acknowledge back. That means consistency is always gonna be ensured. Is this clear, Venu? Okay. Okay, Prakhar says thank you. Okay. Okay.
I think there's one question.
Okay, Aman has asked one question. Okay, so Vinu, let's take it offline. I'll connect with you offline. And Aman says that if node is of size 3 GB and 5 GB is the size of one replica, so if we use two nodes, then node can contain original data and replicated data. Okay, great. So first of all, Aman, I want you to understand the concept of replication. Why exactly or when exactly do you do the replication, right? You replicate when you want that in case one copy of the data is lost, you have got another copy available. Okay, now let's take it step by step. So you are not going to store the original copy and the replica on the same node. If you do that, in case that particular node is lost, you will lose both the copies of the data. That means purpose of replication is not achieved in that manner. Now his question is, node is of size 3 GB and 5 GB is size of one replica. Okay, if we use two nodes, then node can contain original data and replicated data. Okay, so two nodes are gonna give you a space of 6 GB. Okay, and 5 GB is size of one replica. Now I want you to understand one thing here, is that when we say size of replica is 5 GB, that simply means that one copy of data is of this particular size. But when it comes to storing that data on actual physical hardware, it is not the case that you store it in entire one chunk onto one particular server. The data is further divided into chunks. That is something called as block size. If you have studied or have a little bit idea about HDFS or any distributed file system, the data is divided into chunks or something called as block size. These block sizes are stored. So for each block size you are going to have, now each block size is gonna smaller than the capacity of the individual node, and these blocks are in turn stored in a replicated manner. So that is how it's stored. Was I able to answer your question, Aman, or is there any other doubt? Okay, thanks, Aman. Okay, great. Okay, great. So I think we are about the time, and it's already 1 o'clock. So we are gonna wind up the session. And if you have any doubt, please feel free to respond on the WhatsApp group found for our meetup, and we'll definitely respond. And we can also get on one-on-one discussion. We would love to, right? I and Manisha are always enthusiastic to discuss these concepts, right? So thanks a lot, guys. Thanks for joining. Thanks for your time. Thanks, Neeraj. Thanks, Ashish. Okay. Bye bye, everyone. Take care.
Guys, just before you leave, I have put up one question.